To open up Multisim, double-click on the icon on your desktop, the NI Multisim 14.1 icon. Will open up a new design for you. This is typical CAD Windows-based software. So you've got your basic menu bar at the top here. You've got your user icons. This guy here is for simulating. You have your instrumentation down the right hand side. So your instruments consist of things like voltmeters, ammeters, ohm meters, oscilloscopes, function generators, those kind of things. If some of these items are not displayed on your particular version of Multisim, you can go to View and then down to Toolbars, and you can see that you can click on each of these. So here's the instruments, the simulation, components, the main, the view, the standard. So these are the standard items that you'll see on a toolbar. We have scroll bars, so you can scroll to the edge and the lower edge of your drawing. Typically on a CAD drawing we put a title block in here. So to place a title block, you go to the Place menu item, go down to Title Block, and I like to use example 1 and open, and then just move it around till you're happy with its location and just click the mouse button. You'll notice it has a place for the title and the document number. So if you just double click on it, in the title you can write in something like example 1, and in the document number you can put in your name. When you're finished, you can click on OK. You'll notice the title block is still highlighted, so if you click anywhere it'll stop highlighting it, and the title is example 1 and the document number is Darren Holmes. I'm going to scroll back to the left top because I want to put in a small example circuit for you here. So to put in your schematic, all you need to do is go to Place, Component, and in the group, the first thing I'm going to do is go to Sources, and I want to go to Power Sources. So I'm going to select VCC, say OK, and just drop it on my schematic page. I'm going to close it for a second. When I place VCC, it automatically puts 5 volts, so if you double click on it, you can actually change it to a different voltage. You can go to 12 volts or whatever you need. So I'm just going to leave it at 5 volts. I'm going to place a few more components. So in the sources, I need a ground. So I'm going to click on OK and place a ground somewhere over here. I'm going to change my group to Basic, and in Basic I know I'm going to need a switch. So we have different kinds of switches here, so I'm just going to click on Dip Switch 1, and that's a standard switch. I'm going to say OK, place it about here. I know I'm going to need a resistor, so while I'm in the basic group I can click on resistor, and notice it gives you all the resistor values. So I'm going to start with a resistor value of 330 ohms and say OK and put that in my circuit. And I want an LED, so I've got to change my group from basic to diodes, and in the diodes I want an LED, and I think I'll use a red LED. I'll click on OK, and I'm going to place my LED right about here. Now I want to know what the voltage drop on an LED is and how much current flows through an LED. So for that I'm going to go to a group called indicators. And in indicators I've got a voltmeter. And these are horizontal, so the input's on one side and the output's on the other. So I'm going to go to voltmeter vertical. Say OK. And put it in beside my LED. And then I want to know how much current's going to go through my LEDs. So I'm going to click on ammeter, and I want it to be vertical as well. OK. I'm going to place it down here. And I think that's all the components I need for now, so I'm going to close. Now my ground needs to be moved over, so just click on it and drag it over. Now to wire this circuit together, all you have to do is go to your first component, and you'll notice the pointer turns into a crosshair. So just do a mouse click on it and drag it down, and then drag it over to your first item and click on it. And that'll put the wire in for you. Then I'm going to put my next wire in, click, move it over, click, and then my resistor to the LED. So click, over, down, click. Then my LED to the ammeter to ground. And then I want to connect the voltmeter across my LED. Now this is a nice CAD drawing, but I can also simulate this circuit. So if you go up to this little play button here where it says run, or you can press F5, so click on that, and you'll notice the LED is clear. So if I come over to my switch, you'll notice that when my pointer gets to the switch, it turns into a little hand. So I can use that to open and close my switch, or I can press the A key. So I'm going to use the pointer and close the switch. Notice the LED is now red, indicating that it is on. Current is flowing through my circuit. It's 9.732 milliamps. And the voltage drop on my LED is 1.788 volts. To stop the simulation, you notice there's a little square button up here. It's red, and when you hover over it, it says stop. This will stop your simulation. In this next example, I want to build a small digital circuit for you. I'm just going to put an AND gate in there. So I'm going to go to Place, Component, and my group is going to be TTL, and I'm going to place in a 7408N, and I'm going to say OK. It's going to ask me for what gate I want, whether it's A, B, C, or D, so I'm going to click on A. So this is my AND gate. I'm going to place it about here. Now it asks me if I want another one from the same IC or one from a new IC. I just want the one gate, so I'm going to press cancel. Next group, I'm going to go to sources and power sources. I know I'm going to need a ground, so I need a ground for my output LED. And I need a ground for my switches. I'm also going to need VCC of 5 volts. Now notice it says hidden power pins are using hidden on-page connectors with the name VCC. Place this global connector will form a virtual connection to those pins. Do you want to continue? Yes. I'm going to close here for a second. So what's it talking about? This gate here has 2 pins. One's power, one's ground. right? One's VCC. So the VCC on this IC is going to connect to this VCC symbol. The ground on here is going to automatically connect to my ground symbols. Perfectly okay. I need to go back to place, component. I'm going to change the group to basic. I know I need 2 switches, so dip switch 1, okay. So this will be my first switch. Then I'm going to place a second switch. I know I'm going to need a resistor, so resistors are in basic. Resistors. I know I need 4.7K for those pull-up resistors, so I need 2 of those in my circuit, so I'm just going to drop one and then drop a second one. And then I know I need a 330 ohm resistor. To go to my LED, and I know I'm going to need an LED, so the LEDs are in the group diodes, LED, red LED, okay. So I'm going to throw that in my circuit. So here's my resistor 1. It would be nice if it was rotated, so I'm going to right click on it and I'm going to rotate 90 degrees clockwise. Same thing with resistor 2, right click, rotate 90 degrees clockwise. So R1 is going to come down and go to the first switch, so I'll place it about here. R2 has to go to the second switch, so I'll place it about here. I'm going to move VCC over and down a little bit. And now I'm going to wire this circuit up. So I click on VCC, go down to R1 and click on it. R2, click on it, up and over to the line, and notice it puts a dot there where it connects it. I need to hook up my switches to ground and the other switch to ground, so it puts a dot there where there's a connection. Now I notice that switch 1 is operated by key A and switch 2 is operated by key A. So if I press the A key, notice both switches operate at the same time. So on my second switch, I'm going to right click on it, and it's gone off the screen here, but down at the bottom if I have a properties box and it says key for toggle, I'm going to select B and say OK. So now when I press the A key, just switch 1 works, and when I press the B key, just switch 2 works. I don't like that switch 2 is right underneath key A, so I can click on just the S2 and I can move it. And I might just as well click on S1 and move it as well. Now I need to hook up the output of my AND gate to my resistor, from my resistor to my LED. And sometimes it takes a couple tries to get it down there, and then click on it when you're happy with it. And then the output of the LED to ground. And now I need to hook up my switch to my AND gate. So I'm going to go down, and notice when I go over, the bend follows it. I really don't want that bend following it back and forth. So when I'm happy with where the bend is, if I hit the left mouse button, it anchors it, and then when I move over, I can join it. So right there I'm going to hit the left mouse button and then go over to my AND gate. Now I need to hook up these resistors. So there's the first one, and there's the second one. Now, when these switches are open and closed, I'd like to monitor what the voltage is going to be on these two lines. So I'm going to do that with a voltage probe. I'm going to go to Place, and I'm going to go to Probe and Voltage. So now I can bring in this voltage probe and I can put it on a line. So you notice when it reaches a line, it turns to yellow. So when you're happy with the placement, you can just do a left click on it. Now you'll notice it's going to give me a whole bunch of voltages here. Frequency, DC, RMS, peak to peak. I don't want all those. So I'm going to right click on it. I'm going to go to Properties. And then I'm going to go over to Parameters. And I want to do Custom. And the only thing I really want showing is volts DC. So all the others I'm going to say no to. So the only one I have said yes to is volts DC. I'm going to say OK. And you notice in here it's just got volts DC. It's highlighted right now, so I'm just going to click somewhere on my schematic to stop it from highlighting. So now I want to simulate it, so I go up to my play button or the run button or press F5. And now it's running the simulation. You can see that key A is up and key B is up, and that's providing 5 volts to my AND gate. So 5 and 5 volts is logic 1, logic 1. The output is logic 1. So when I press the A key, I'm now inputting a logic 0. And please notice that the volts DC is 10.6 picovolts. Picovolts are very, very small. I don't know why it doesn't say 0. I'm not really worried about it. And when I press the A switch again, you can see that my LED is on. Before I can make any changes to my schematic, I have to stop the simulation. I can tell it's simulating because the red button is highlighted up here where it says stop. Also, the design one is simulating, and you can see that it's actually simulating by this green bar going back and forth. So I'm going to stop the simulation, and now I can make modifications to my circuit. So once you've got your circuit set up correctly and you've done a simulation and you're happy with it, you can go up to the print icon and print your circuit out, or you could save it and submit your circuit. What I like to do is to incorporate this circuit into a Word document. So I'm going to bring up Word. And the first thing I like to do in Word is put in a couple of blank lines. So on the top line you can label it example. And I usually like to highlight this, and on the home screen you can increase the font size, make it bold, center it, that kind of thing. And where I want to place my schematic, I can go back to Multisim and just drag a rectangle around everything you want to copy over. And then on any item, do a right click and copy. Then go back to Word, and in your Word document, sometimes you can do a right click paste, or you can press Control V, and that'll paste it into your Word document. You can click on it, and you can center it. You can rescale it to a different size. So I might like to put in a Boolean expression down here. To do that, I go to the Insert menu item, and I come over here to Equation, and I click on Equation, and then I go into Inc Equation. So in the Inc Equation, I can write in a letter like A and put a bar over it. I can put in an OR. I can put in a B. I can put a bar over it. Now notice it's come up with a 5. It's got the OR correct, but it's come up with a 5. So I can go to Select and Correct. And I can draw a dotted line around the B. And then I can select the B. So now you can see it's got my equation correct. So I can do Insert. So now I've inserted my equation. What if I want a bar over the whole thing? I can highlight both of them. I can go to Accent. In an accent, it's got over bars and under bars. So if I click on the over bar, it puts a bar over both of them. If I click somewhere else, it gets rid of it. So I can select this, and I can change the font size. So I just wanted to show you that you can put in a schematic into a Word document, and you can put in Boolean expressions into a Word document. In Multisim, I have drawn the circuit from lab number 4. It's the schematic for part A, combining logic gates. And what I wanted to show you was that there is no pin numbers on any of these gates. The way to get the pin numbers showing, you can go up to Options, go to Sheet Properties, Sheet Visibility, and over here where it says Package Pin Names and it's got a square box in there, click on it and it'll give you an empty box. Click on it again and it'll give you a check mark. Then say OK. And now it puts the pin numbers on the gates. So the 7408, gate A, pin 1, 2, and 3, 4, 5, and 6. And on the 7432, 1, 2, and 3. But also notice over on the LED, it brings up the A for anode and C for cathode. And also on the switches, it brings up the 1 and the 2 on the switches. If you don't want these numbers on the switches or the LED, go back to Options, Sheet Properties, turn off the package pin names, and instead do a right click on the gate, go to Properties, and instead of using Sheet Visibility Settings in Display, use Component Specific Visibility Settings, and click on the Show Package Pin Names. Then click on OK, and it brings up the pin numbers just for that gate. Do the same thing for the second gate. Go to Properties, use Component Specific, Show Package Pin Names, OK. And on the 7432, right click, go down to Properties, in Display, use Component Specific Visibility Settings, Show Package Pin Names, OK. Now you have just the pin numbers on the gates that you want to have the pin numbers on, and you don't have additional pin numbers on the switches or on the LED. So you may recognize this particular schematic. It's from Lab 4, Combining Logic Gates, and it's the lab schematic from Part A. And you can see here that I have A, B, and C on my input. So the expression was AB or BC. So A is 1, B is 1. My output was 1. On the other half of the expression is OR BC. So if A is off and B and C are both 1, the light is on. So before we get back to today's lab, I want to show you one more item that Multisim can do. I've stripped out the inputs, so all those switches and resistors are gone, and I've stripped out the output, the LED and the resistor. We're going to go down our instrument toolbar here, and we're looking for one called a logic converter. So if you click on the logic converter and place it in your circuit, and if you double click on it, it'll bring up the logic converter properties box. You'll notice it has inputs and it has an output. So the inputs A, B, C, D, E, F, G, and H correspond to these input lines down here, and then the last one is your output. So we're going to use A, B, and C for inputs. So click on A, B, and C. Notice it fills in the truth table for you, but it does not know what the output is yet. So on the schematic, I have to connect A to my A input, B goes to the B inputs, and C goes to the C inputs. The output connects to the last pin. Now over here on the logic converter, the first conversion it does is from logic gate to truth table. So click on that and it fills in the truth table for you. Identical to lab number 4's truth table. The next item goes from truth table to Boolean expression. So click on that, and notice it gives you A0 BC followed by A B C 0. So this is A B C 0. Okay, so it doesn't put the bar over it, it just puts this little tick here indicating it's C 0. And the next item I want to show you is it goes from truth table to simplified Boolean expression. So here we have the AB or BC.